Hello friends, hope you all are doing fine. In the last video of this OpenGL video series, I introduced you the model mesh class. I designed it to represent a drawable entity in the scene. That class did the job, but I am not quite happy with it. So I am going to redesign this class and introduce you the component based architecture. This concept is very popular in game development industry and there are many ways to implement it. Here I am going to present you a very simple way to do it, and it actually works quite well. Okay, in the object-oriented programming, when we need functionalities of another class, we use inheritance. When we extend to a class, that class becomes a superclass and its functionalities will be available to the subclass. But in the component-based architecture, we prefer composition over inheritance. In that way, it is very easy to add new functionalities to a game entity. Okay, now I am going to show you how did I implement it. First of all, I introduced the game entity class and the iComponent interface. As you can see, the game entity class has a list of components. And also, I have added the model matrix as a member of the game entity class. Also, there is a function called addComponent to add a component to the game entity. And there is a removeComponent function to remove a component. Then we have update function which takes the time step as an argument. And then I have added a getter and setter for the model matrix. Okay, let's go to the source file. In the constructor, we initialize our model matrix to an identity matrix. And in the destructor, we delete all components and clears the list. Inside the addComponent function, we add a new component to the list if it is not already present. Now let's go to the iComponent interface and see what does it look like. It only has two pure virtual functions for now. The getComponentType function should return the component type as a string, and it is the child class's responsibility to return a unique string as the component type. Then we have update function which takes game entity and time step as arguments. Inside this update function, component update its game entity based on the component's logic. Okay, now let's go back to the game entity. As you can see, the addComponent function checks the component type using getComponentType function. RemoveComponent function removes the given component from the component list. And inside the update function, we update all components. Here we pass this game entity and the time step. And these are just a setter and getter for the model matrix. Okay, now let's go to the ModelMeshComponent class. This is our ModelMesh class. Now I have converted it into a component. As you can see, I have extended it to the iComponent interface. Then I have removed the draw function and now the model shader is a member of the ModelMeshComponent class. And we should pass it in the constructor. Then I had to override iComponent interface functions, the getComponentType and the update function. In ModelMesh class, we had the model matrix as a member, but I have removed it here and we can get it from the game entity when required. Okay, now let's go to the source file. Okay, in the constructor, we set the shader and the loading model and creating OpenGL objects are the same as in the ModelMesh class. Okay, let's go to the getComponentType function. As you can see, I am returning a string as the component type. This should be a unique string. And in the update function, we bind our vertex array first. And then we set the model matrix and we get it from the entity. Then we draw our vertices. Okay, those are the modifications. Now let's go to the main to see how we can use these classes. First of all, we need to include the gameEntity.h header file, and then we also need ModelMeshComponent.h header file. Then we can create a game entity. Here I am creating a game entity called table. Then I am adding components. Here I add ModelMeshComponent. I need to pass the model shader and the obj file name in the constructor. and then I set the model matrix. In this case, I set the identity matrix, so the table will be drawn in the center. And then inside the game loop, I call table.update function and pass the time step. Okay, now let's try to run this and see the result. Okay, as you can see, we can render our objects into the scene without any issues. Okay, now let's add another game entity into the scene. Now I am adding a box object. I create the game entity called box, and then I add ModelMeshComponent as before. This time I pass the box.obj file. Then I need to set the model matrix. Here I will create an identity matrix first. And then I call glm translate function to create a new matrix which is translated. The translated amount is given as a 3D vector. This time I translate it by 10 units along the z-axis. Okay, now let's go to the game loop and let's call box.update function. And that's all. And let's try to run this. Okay, now we have two objects, a table and a box. Okay, now I want to show you something else. I have created another component called manual control component. By using that component, we can move objects within our scene using our keyboard IJKL buttons. Okay, now let's go to add that component into this box object. Okay, now I am calling box.addComponent new manual mesh component, and then I am passing mouse and keyboard through the constructor. Okay, now we can try to run this. Okay, as you can see, now we have both objects and I can move the box object using my keyboard. When I press IJKL keys, the box moves. Now you can understand it is very easy to add new functionalities using this component based architecture. Okay, now let's go back to see the implementation of manual control component class. Okay, the manual control component class is derived from iComponent interface and also derived from iMouse event handler interface. So let's go to the source file. Okay, in the constructor, this class is registered with the mouse in order to receive mouse events. And in the destructor, we unregister from the mouse. And in the getComponentType function, we return string component type. And in the update function, we have the logic to create the model matrix based on key events. That's all for this class. This is very simple implementation, and that's all for this video. I think you got an idea about component based architecture. Okay, thank you.